times I'm working with kindergartens and we're working on pixel art, and other times I can be maybe in a physics 11 or 12 class and we're kind of laser cutting or doing 3D printing on the other end of the spectrum, and everything in between. So I spend a lot of time with different technology in different schools with different grades. And one of the programs and what we're going to talk about today is Tinkercad. And that program is a 3D design program created by Autodesk. And it is basically a great introduction into 3D design. And it also, within it, it has a circuit program within it. And within that, it also has a block-based coding program. So from when I started with the Tinkercad, it's kind of expanded out into 3 different areas. We're just going to be talking about the 3D design program today, but maybe I'll mention a little bit about the other 2 programs. So Tinkercad jumps from when you're feeling confident in Tinkercad, you can jump into a more advanced design program, more advanced computer-aided design program called Fusion 360. So we use that in our high schools. So the students kind of up through primary, middle, they focus on Tinkercad for 3D design and building. And then as they get into the high school, they kind of gradually move away from Tinkercad and then focus more on Fusion 360, which is an industry-based program which they use for CNCing or 3D printing or laser cutting. So as I mentioned today, for those people that just came in to the call, if you could pop in where you're from and what you do, that would be awesome, just so I get kind of a demographic of who you are and who I'm with right now. Today we're going to be kind of looking at Tinkercad, and I'm going to walk you through the process. So what I'm going to do is, you're more than, like I mentioned before, you're more than welcome to follow along with me. So right in Richmond, awesome. Teacher from Interior BC, cool, right on, that's awesome. I'm kind of Interior BC, Rossland, so I don't know how interior you are. I think interior like Okanagan kind of area. And North Van, Caslow's very close, SD62, right on. Great, Langley. Okay, cool. We've got people from like all kinds of different places. That's awesome. Victoria, right on. I grew up in Sydney, so yeah, the island's a wonderful place. Far away from me right now, though. Okay, so let's get into it. So what I'm going to do here is I'm just going to share my screen. Give me 1 second here. And you should be looking at my screen now. If you can just give me an OK on the side, that would be awesome. You should see my Tinkercad screen. Sometimes that thumbs up, sweet. I'll take a thumbs up. That's good. Sometimes you're like doing things, you have no idea, and no one will tell you, and you're way far in, and you've been on the wrong screen. So what I'm going to suggest right now is you go to Google and you just type in Tinkercad. And Tinkercad will be the first thing that pops up on the top. And if you just click on Tinkercad, it will take you into Tinkercad. Obviously, I'm already logged into my account here. If you just pop up in the top corner up here, you can log in and just create a personal account up there. So I'll give you, if some of you are running 2 monitors right now, I'll give you a couple of minutes to kind of log in and get that ready. If not, just listen to what I'm going to kind of walk through here and just follow along. Now, Tinkercad is really cool because one of the other things it has is it has a classroom portion in it. So if you look over here on the side where it says classes right here, I have a number of classes that I work in. Some have 0 students in them. Obviously, I didn't use those ones, but I have a lot of full classrooms that I use whenever I go out to the schools. And I basically pop them in a classroom and I have a template ready for them, ready to go, that they work on. And this template that I'm going to show you today is an example of our most recent template that we're working grade 5 through 9 with it at varying different levels. But this classroom feature is really cool because you can go in and you can look at all of the individual projects that students are working on. And you can alter them, and you can pull them out. You can take, grab pictures of them. There's a lot of different things you can do. I prefer to for students to put their work on e-portfolios. So, we use Google here, but there's a lot of options for that. So it's a great option for controlling and seeing all the students' work in the same place. So I just wanted to mention that before we get into it. Now, the project that I'm going to walk you through today is a combination of kind of a couple different things. The first thing is it's using the microbit. So we use the microbit as a microcontroller in our district. It's kind of our standard microcontroller. And we use it for all kinds of different things, but robotics is kind of a key thing that we walk through with our students. So what I'm going to do, if you have your Tinkercad ready to go, or you have it up in front of you, if you have your account ready to go, I'm just going to pop, hopefully everyone can see that. I'm going to pop a link into the chat there. And if you click on that link, that will take you to a design. If you have an account, you'll be able to actually go into the design and follow along with me. If you don't, that's okay. Don't worry about the link. But if you do have an account right now, please click on that link and it will take you to, and I'll just go in here. It will take you into a place that looks like this. Okay, and I'll talk about what's going on here. For those of you that this is your first introduction to Tinkercad, I'm going to go through very slowly what's happening here, so don't feel overwhelmed about what's going on the plate right now. This is simply a template that I develop when I'm working with students and we're doing 3D printing. So before we even look at what's happening here, I just kind of want to walk through the entire kind of area, what's going on in the editor. So let's start. Oh, sorry, go ahead.
Copy and tinker or download?
Copy and tinker. Yeah, that'll take you right into it. If you click on copy and tinker, it'll take you basically into the design that looks exactly like this, and it'll make a copy in your account. If you download it, it will download the model as an STL for 3D printing, which, yeah, this isn't really ready for 3D printing, so that we'll talk about that in a second. Hopefully everyone's okay with that. And keep in mind, if you have any questions, pop in. I've got my chat open on my right-hand screen here, and I'm like working on my left-hand screen. So please, if I'm doing anything that's going too fast or you have any questions, please ask away on the chat. Okay, going back to where we are here in the editor, you have a couple different things going on here. Up on the top, you have the name of your design. It usually gives it a really strange name to start out with, like funky something, or it's all these kind of strange names. So one of the first things you want your students to do is to name their project. Over here, this will take you back to your library if you click on that. Over here, this is a control box. So if I left click this with my mouse and I grab it, I can go and it will move my plate around, essentially my editing plate. Now, if I click on it, it will rotate to that area, and we'll talk a bit more about that and how useful that is in a little bit here. So this is kind of like a little cube you can grab. As you move down, there is a home view that is very handy. That's one of the first things I always show students. You click on the home view and it will always take you home. It's pretty easy to sometimes get lost in Tinkercad. Like if I don't know where I am, I can always click on the home view and it will always bring me back to where I want to be. This one right here is a kind of fit all in view. Don't worry about that. This is a plus and a minus. So I don't really use those. I just use my mouse wheel to scroll in, to scroll out. I find I don't really use these two very much. This one on the bottom here is an orthographic view. So it's really handy when you are getting into kind of more detailed design and you want to be very exact. So if I click on that, you'll notice it basically takes away the 3 dimensions on my project. It makes it very flat. So for example, if I click on the top view here, you can see it flattens everything out. So it's easy to work with measurements. If I click it again, it kind of gives it that 3D view. So the orthographic view is very handy for when you want to do specific measurements in a specific area. I'm going to stick it in 3D for now. Now, on my actual plane here, if I left click and grab, it creates a bounding box. Sorry, do you have students to use laptops or iPads? They can use both. I can use iPads sometimes in primary, younger grades. It's easier to use iPads because they're used with a touch screen, because Tinkercad is actually an app on an iPad. You can use it on the browser, but it's better to use the app, and you can do most things with it. So you're fine either or. Personally, I prefer a laptop, but with primary, we use iPads sometimes. So back to here, sorry, the bounding box is left click and grab, so I can highlight all my pieces with that. More importantly than that is the right click mouse button. So the right click will kind of rotate me and move me around my plane. Now it can be a bit confusing when you first do it. You're like, oh, don't know where anything is, but you gradually get used to moving around a 3D design plane. Now you'll notice already I'm having trouble seeing some of my objects. So the next thing you want to understand is after the right click is you push down on your middle mouse button and you can pan. Pan is panning your camera up, down, left, and right. So that's really handy to know how to do that because that allows you to get to certain parts of your plane and kind of so I can rotate around here. I can pan. I'm clicking on my middle mouse button. I can get to a different spot. But I'm just going to click on my home button to take me back to home because that's where I want to be. If you don't have a mouse, you can use a trackpad. It's okay, but I would suggest using a mouse. If you don't have one, let's see, I've got my trackpad in front of me here. And I am left clicking, I'm right clicking on my trackpad, and that's moving my my plane like that. And left clicking on my trackpad is doing that. So right clicking on my trackpad and left clicking on my trackpad. So you just have to find what works. Now, I think trackpad, I can't remember exactly. I'm going to shift and yeah, trackpad is very difficult to use. I would suggest with a class that you get a set of mice. It's just a lot easier for 3D design. Um, okay, so back to where we were here, just moving around our design space. Coming over to the side, you have a number of settings. Now, if I click on that, it gives me the measurements. You don't really need to worry about this unless you want to work in something other than millimeters, like inches. I don't know why you'd want to work in inches, but you can if you want. And these are presets. Now, this one right here, this width and this length, this will make your entire workspace bigger. So you can, if I take this 200 and I delete it, I type in 500 and I make that default like that. So I'll also make this 500 as well. On the length, that's 500. Oh, it'll bump it up accordingly. It'll make my workspace just way larger. You can see if some students are like, I don't have enough place, I don't have enough room to work in, they can always click on settings and they can bump up the size. Personally, I'm gonna leave it at 200 by 200 because it gets a bit unwieldy. So just gonna leave it at that and keep it nice and simple. Down on the bottom, you have a button called Snap Grid. If you click on this button, you'll notice when I grab something and move it, it kind of snaps and it moves in 1 millimeter increments. Let me just zoom in here. You can see it's moving in 1 millimeter increments. So if I click Snap Grid and I turn off, and let's say I grab this again, it's moving in 0.001 increments. So it's very, very small increments. I would suggest when you're starting out, you leave it at 1 millimeter until you become more comfortable with it. And then you can move up to, I generally switch to off when I'm ready. Up on the top up here, you have some different things. We're going to talk about these in a minute. We can't use them right now. Import and export, that's for bringing files in. This is for sending your file out if you want to 3D print it, or you can take your file and place it in something like CoSpaces, which is a 3D game design program. For example, if I make like a key in here and I want to put it in another program, I export it, or if I want to 3D print it, which is what we're going to talk about here. This send to, you don't need to worry about that. That's sending to other people so they can work on the design with you. Up on the top, you have some kind of interesting other buttons here. This is a Minecraft button. Kids are always interested in this one. So if I click on that, it'll take my design and it'll turn it into Minecraft. You can actually export things and put them into Minecraft if you want to. I don't usually do that, but you can see it has all the different types of blocks that you use here. This one is a Lego one, which I find really interesting. So you can click on this little stairs here and it will show you how to build your design out in Lego. You can see if you have like all those, you need a lot of little tiny Lego pieces. My screws have turned into blocks, but whatever. It's kind of cool, right? Like you could have a design and you could basically learn how to layer it out and build it out in Lego. So, and you can bump up and see how you build it piece by piece. So that's kind of a neat function there. Yeah, so I'm going to go back to regular right here. So I think that's pretty much, we've covered pretty much everything in the works, the editor here. Now, one of the other main things, and I've got a little arrow here, is all of your shapes. And this is kind of your workhorse that on the side here. This is what you work from, and this is how you build. So you have a lot of shapes. We're just going to be working, I think, with the basic shapes today. But if you click on this arrow here, you can see you have like design starters. So you can have like all kinds of numbers and letters. You can have creatures. So students can build out, and you click on more shapes. I mean, it goes on and on and on. There's lots of different things you can build. When I'm working with primary, I often have the students building out characters for our stories. And we often go into these areas in here, creatures and characters. You have vehicles and machinery, structure, and hardware. Hardware is a really cool one, actually. You have all these snap pieces you can use. And you can get into other pieces like electronics. So if I click on the electronics one, you can see I have things like an Arduino. I have motors. I have the microbit, which you can see on the top right there. LEDs, and these are all to scale. So if you ever want to work with electronics and bring it into your design, you can use these scale pieces on the side and use them. So that's kind of what we're working on today. So I'm going to go back up to basic shapes, and I'm going to stick with the basic design right here. And I'm just going to close that up and bring it over to the side and just kind of rotate my design this way. Now, what this is, it's kind of hard to tell what is actually going on here, is there is a project by a company called Kitronics, and you build a robot. Now, the robot comes with these motors. So it comes with this motor. It has a microbit, and it has batteries, and it has a little driver here. This is what drives the motors. It also comes with a ping pong ball to drive the little robot around. Now, it's pretty cool, but it comes with a really flimsy cardboard case, which isn't really that good for design. So this project that we have the students work on from like 5 till 9 is designing a chassis for the robot. Rather than using the cardboard, we have them design a chassis out to hold the motors, to hold the ping pong ball, and to hold everything together, because the cardboard chassis is just doesn't cut it. So what you want to look at here is once you've got your design kind of on the side ready to go, is you'll notice that when I click on something, for example, if I click on this wheel right here, there is a shape icon that pops up. And if I click on the color, I can change the color of the shape icon. So I can go any color I want. I can come down to multicolor here. I can do a custom color, and I can, bump the hue and saturation and change all that around. So I can, first thing to notice is you can change the color of the different shapes and even that ping pong ball, but I'm going to leave that as white for now. And what we're kind of looking at here is, if I come over to the side, I'll close this up, is we want to create basically something to hold this motor. The wheel right here attaches to the motor. We'll do that in a bit. But we need something to hold the wheel to the microbit right here. We need something to like attach it so it hangs on to the side of the microbit chassis. So that is kind of our design challenge, if you will. Our prototype challenge is to create a chassis that's going to hold the motor driver onto it. So in order to do that, we want to think about a couple things. First of all, our workspace here is very cluttered. There's a lot going on. So what I'm going to do is I'm just going to kind of grab things. I'm going to take the ping pong ball. I'm going to left click it, and I'm going to drag it off to the side. Now, if you grab the ping pong ball by any of these white little squares, you'll pull it and you'll change the size of the ping pong ball. You want to make sure, and I'm just going to back up by clicking the arrow, that you drag it just on the white part. Left click and drag the white part. So I'm just going to move it over there. I'm going to grab the wheel here, and I'm going to move that over there. And I'm just going to kind of move things off my plate here so I have more room to work with. So I'm going to come in. This wheel, I don't really need it right now. I'm going to kind of drag it and put it off to the side. So I'm kind of left with these screws right here and this motor. So I'm just going to kind of left click and move my way around, come in a little closer. I'm going to click my mouse button, and I'm going to try and put myself kind of in a comfortable position right here where I can work from. So I'll stop for a second, and I'll just see, does anyone have any questions so far where we are, or any comments about this piece, or oh, there's so many tutorials for Tinkercad. If students want to learn it on their own, you can just click on Tinkercad and they have like a full set of tutorials that go in and take you all the way through the process from designing from nothing up. If they wanted to learn it on their own, there's lots out there, and just a quick search on Google, and you'll find like thousands of tutorials on it. What am I trying to make? So basically what I'm trying to make is, this is a motor. This wheel attaches to the motor right here, and this motor, we want to attach it to the board. Then this ping pong ball sits on the front right here and acts as a front wheel. And then the students basically use another microbit and connect this to this and drive it around like a little robot. Let me see. Actually, I might be able to let me see if I can find that for you really quick. It'll be a little easier for you to envision if I give you the link to the, give me 1 second here. I'm just jumping into my Google Drive. I'll give you the link on the side. You can see the actual robot. Give me 1 second. Okay, I think I've got it. Okay, here we go. And if you click on the link on the side right there, that is what essentially what the model looks like, that the students put together, and we want to design the same thing, if that makes sense. Let me bring that in here so the rest of you can see that. Give me 1 second. Okay, I'll go into here and I'll show you the model real quick. Here we go. So it looks like this right here. You can see here is the design right here. No worries, sorry, I should have shown you that at the start. I was talking too much. This is the design, and we kind of want to recreate this design. That's the idea. Okay, so back to where we were. This is kind of the part here that we want to create the chassis that hooks on. So the first thing I'm going to do is I am going to come over to the side. I'm going to click on this little arrow here, and there is a red square or a red box here. So we want to start working with the basic shapes as kind of our basic design chassis. So I'm going to left click the square and I'm going to bring it out and I'm just going to put it down onto my work plane. So when you click it, you can just drag it around, put it wherever you want. Like I talked about before, you'll notice that if I left click any of these white dots and drag them, they will change the size or the height of the cube. So for example, if I click on, I'm going to zoom into the cube a little closer. And if I click on this little white square here, or this white square here, or this one here, or this one here, they are giving me the dimensions of the cube. So it's giving me the depth and the length. So for example, if I wanted this cube, specifically the depth, to be 30, I would type in 30 here and hit enter. And it would now make the depth of the cube 30 millimeters. And if I clicked on this side, I typed in 30. It would also make the depth, the length of it, 30 millimeters. So if I want to click on the top, which is the little white square here, I can click on here, type in 30 and hit enter. And I can alter the size of the cube according to the dimensions that I placed in. As I mentioned before, it's all in millimeters. So if you were to 3D print this out, it wouldn't be this big. It would be much smaller. And I always make sure I have a example to show the students of what a 20 millimeter cube actually looks like. So I'm going to back up. I'm just going to click my little arrow keys there. So I'm back to my regular, I think actually if I keep backing up, I'm back to my regular 20 by 20 millimeter cube. So what I want to do is I want to create a kind of a base that this little motor driver can hang on to. So let me drag down. What does steps mean in the drop-down menu for the cube? Steps. So steps, I think that's, I'm not sure exactly what steps is indicating actually. I don't notice any difference in it. I don't, you can, you're altering things like the radius. The steps might be, So the steps is how many polygons it's broken up into. So if you can see I increase it to 20 steps, it basically increases it to 20 polygons. So I don't use this over here very often. I try and stick with, I mean, you can use it if you want, but I generally stick with this part right here, keeping my dimensions fairly simple. But if you wanted to get over here, you can also alter it using your drop down as well. It's up to you. So what I'm going to do is this part right here, I'm going to click this little top part and I'm going to pull down with my left mouse and I'm going to drop this down to 3 millimeters. So you can see I just came in and I just can pull this up or down. If I don't want to do it that way, I can just click on the white dot and I can type in 3 and hit enter and it will also drop it down to 3 millimeters. So there's two different ways you can do that. Whichever way is easiest to you is it's totally up to you. I prefer to actually type it in because then it's a little bit faster. So once I've got my basic kind of platform here, I'm going to kind of look, I'm going to back out and I'm going to kind of look over and I've got this motor driver over here. So this motor driver right here, I want to kind of turn it and rotate it down. You can see the motor driver right now is sticking straight up. And on the top of the motor driver, there's an arrow and there's these double arrows kind of on the different sides. There's one on the bottom, there's one on the left, and there's one on this side. So if you click on one of these double arrows and you pull, you can rotate your piece. Now that way I'm rotating on this axis. If I click it again and I grab this one over here, I am rotating on this axis. And if I grab the one on the bottom, I'm rotating around that axis. You can see there's 3 different axes, your X, Y, and your Z, that you are rotating on. Now you'll also notice, and I'll zoom in a little bit so you can see this, when you rotate, if you hang your mouse like inside this circle, it will rotate in 22.5 degree increments. You can see it's just snapping. If I go outside this circle, it snaps in 1 degree increments. So you can do it very quickly like that, or you can do very precise like that with 1 degree increments. I'm going to snap it down to 90 because I want the it to sit like this, like so the wheel goes this way. So I'm going to kind of rotate it that way, and I'm going to bring it over here, kind of just hanging out on this side. Okay, I'll hang tight for a second here. I'll just check in the chat if anyone has any questions about what's going on or what we're doing right now. You can ask, or I'll just continue on. So once we have this motor kind of right here, just kind of hanging out, there's a little black arrow on the top of the motor, and that black arrow will drag your object up or down. And you can actually drag it like below the work plane, or you can drag it out of sight. So we just want to kind of drag it down until it sits on our red piece right here. Now, sometimes you can be in a strange spot. So what I find if I'm ever like my view isn't perfect, I hit F, and F will focus on the object. So if I'm ever kind of like lost, I can hit F and it will zoom in on where I want to look. So what I'm going to do is I'm going to lower this down and kind of seat it on the red square on the bottom. And then I'm just going to I'm moving down, I'm clicking on my middle mouse button here, and I'm going to zoom in a little bit and just rotate around. Now you can see my motor is kind of sitting a bit, it's not really in the right spot. So what I'm going to do is I'm going to bring the motor forward. Now I can left click the motor and drag it forward like this. I can drag it forward, or, so there's another way to move things. I can use my arrow key. So if you don't like using your mouse, you can always use your arrow key to move things around. So I'm going to use my arrow key, and I'm going to kind of move my motor closer to my board here and kind of get it. So it's a little bit closer to the board on the side. Now you notice on the back here, I definitely want to leave a little gap there. I don't want it super tight on the board because I want to attach this motor to this board using this red piece, and we'll talk about that in a second. So you want to get your motor pretty much kind of next to the board like that. So it's sitting fairly close to the board. This is the rotational piece right here that's sitting off the side. So what we want to do is once we have our motor kind of sitting next to our board, we're going to grab our motor again and we're going to bring it up just a little bit. And you can see when I bring it up, I want to bring it up just above that red square that I have on the bottom down there. So it's just kind of hanging out above it. Now this red square on the bottom, I want to get it right underneath the motor. Like I want to get it right on the bottom. So what I can do is I can click on the red square. And again, I'm not going to use my mouse. I'm just going to move it around using my arrow keys like that. So I'm going to use my arrow keys again. Again, I'm going to kind of move it so it's right underneath the board. Okay, don't worry about this white piece sticking in. The actual motor itself, if you look at this design here, actually you can't see it here, but there is this motor, the motors that they use don't have a second white piece on them. This part does not exist on the motors that you use actually from the package, so that's good. Okay, so once we've got our piece on the bottom and it's kind of hanging out down there, we want to get a second piece to come up here to attach, to kind of like hold this in place. We want to like kind of wrap this around, right? So what we're going to do is let's grab our motor again, and I'm going to move my motor back, I think, to about here, and I'm going to wrap around this part. So I'm going to hold the motor in place up around here. So the next thing I'm going to do is I'm going to click on my red plate that's on the bottom, and I'm going to duplicate it. So I'm going to make a copy of it. Now I could bring in a whole new one. I could put it down. I could go through all that. You can duplicate things. So if I click on this, and you'll notice next to the trash can, there is like a square with a bunch of other squares behind it. So if I click that, it makes a copy. Now the copy is actually inside the other one. So you'll see if I'm using my arrow keys, I've got a second copy that kind of pops out like this. What I'm going to do is just using my arrow keys to move around. I'm going to take this copy and I am going to find the part that is the center, that little white square in the center, and I'm going to pull up about there, about, I don't know, 27 seems about reasonable. And then on the side, there's a little black square, and I'm going to push in to about 3. So you can see now I have this little square piece sitting on the side. So I've got my square piece on the bottom, like there, and then I've got my square piece hanging out on the side like that. So we're kind of almost halfway there of getting this little piece that's going to hold our motor. Now, once we've got our bottom piece and our side piece ready to go, I'm going to click on this side piece, the one that I made over here, and I'm going to duplicate it. So I'm going to click on the duplicate button again, which is this one right here. And I'm just going to use my arrow keys, and I'm going to bring my second piece over. You can see like that. Now I've got 1, 2, 3 red cubes that are kind of hugging my motor piece, that are kind of grabbing onto it. Okay. Now, once I've got those 3 pieces, that's great, but I still can't do anything with them. I want to attach them over to this hole over here, but I can't really do anything with them because if I grab one, it's gonna chunk off like that, and we want to group them together. We want them to be one piece, not 3 pieces. So what you can do is you can click on one piece. So click on one piece, hold down Shift, click on the second piece, keep holding Shift, and click on the third piece. So we'll do that one more time. I'm holding Shift, 1, 2, 3. So I've clicked on all 3 pieces. Now there is a button up here called Group. So if I click on Group, what it does is it sticks those 3 pieces, and if I pull this out, they are now one piece. So rather than 3 pieces, we've got ourselves one piece, which is a lot easier to manage. So we've got kind of our one piece holding our motor, which is a good start. So what I'm going to do is I'm going to click on the motor, and I'm just going to use my arrow keys again. And I'm going to push the motor back, I think, a little bit more, about there. And I'm going to click on my red piece here, and I'm going to move that back a little bit more as well. There we go. So I've got my kind of red piece lined up with my board, and I've got my motor sitting back like that. Now what I want to do is I need to attach this red piece, this piece right here. I want to attach it to my board. So think of this as like it's its own solid piece, and we have to attach it to the board using a screw. Like we want to put a screw through here to attach it, because this is going to be our 3D printed piece right here, the part we're going to 3D print and attach to the main board. So essentially what I want to do is I want to get another cube. I want to attach it to this cube, this part right here, and then I want to put a screw through it, which is going to attach it to the board. So how are we going to do all that? So first things first, this motor I'm finding is kind of in the way. So I'm just going to drag it and I'm going to put it off to the side. So I've got a bit of a cleaner view of what I'm working on. So what I'm going to do now is I could grab a red cube and I can bring it out and I can kind of mess around, bring it up and try and put it in the right spot. But that's going to be difficult. There's an easier way to do this. The work plane, which is this blue graph you see on the bottom, can be manipulated and changed and put in different places. So what I'm going to do is I'm going to click on the work plane, which is this one right here. And if you hover, the work plane will snap to anywhere you hover over. So you can see, I mean, it'll go on anything. So what I'm going to do is I'm going to hover my work plane over my blue board right here. So I'm going to click on that. So I'm going to click on the board. And you'll notice if I right click that my work plane has now attached itself to the top of my board. So if I click on my work plane again and click on the bottom, it goes back down to the bottom. So this way, if I click here, now any object I bring out into my workspace will automatically stick at that level. It's a bit of a strange concept to think of at first, but it saves you time. Rather than moving things up and down and left and right, it'll like be exactly where you want it. Let me show you what I mean by that. So if I grab my box, I pull it out, you'll notice the box is automatically on the level that I want it on. So that's pretty handy for working with. So I'm going to click on the box, hit F, that'll zoom me into the box. And I'm just going to grab the top of the box and I'm going to push it all the way down to about maybe the same level as this piece right here, which is 9 millimeters. Then I'm going to grab this black box on the edge and I'm going to push it in. And you can see I've kind of got this piece and this piece pretty close to each other like that. This piece is actually overlapping a little bit. And if you don't overlap it, if you leave a space in it, when you come to 3D print this, they won't be connected. So you always have to make sure you are overlapping if you want to 3D print it. That's not always the main end goal for a lot of people, but if you do have that option, which I'm hoping most schools have some kind of 3D printer these days, this is a great way to do it. So I'm going to click on the red box right here, and then I'm going to hold down Shift, and I'm going to click on the other piece. So I'll do that one more time. Click on the red box, hold down Shift, click on the other piece, and I'm going to group them. So like this, and you'll notice now I have a full chassis, I guess, or a piece that I can attach to. So if I was to bring my motor and back over here, and like I said, don't worry about this white part right here, that doesn't exist in the real motor. That actually fits right into that piece really nicely. Now, you're not really worried about exact tolerances. I mean, if we were really 3D printing this, we'd talk a bit more about how exactly you want this to fit. But for just practicing and learning, that's a pretty good fit. Kind of fits into it. Now, the next thing I want to do is I have these screws down here. These little they're called M3 screws. They're a certain diameter that work really well with small little robotics. So I want to take one of these screws and I want to put it right through here through the hole. You can see here's the hole on the bottom. I'll zoom in on that. And we want this screw to run right through the hole so it will attach to the board. So we've got a problem. The problem is we don't have a hole running through this piece. So if you put a screw up here, if I was just to put a screw up here like this, it's not gonna, if you were to 3D print it, it wouldn't work. There's no hole to run it through. So we have to create a hole. So what we're gonna do is, first things first, you can click on your piece right here, and I'm just going to hit H. And H allows you to see through it. So it turns it into what's called a hole. You can see over here, there is a solid and there's a hole. So a hole is like a negative shape. So it allows you to see through things, which is pretty handy when you need to do what I want to do right here, which is see where that hole is exactly. So I've got that done. I can see through it, which is great. I'm going to come over to the side here and I'm going to grab a cylinder because the cylinder will be the same size as the M3 screw. The 3 standing for 3 millimeters. So I'm going to grab a cylinder, I'm going to bring it out, and I'm going to put it right here. You'll notice the cylinder comes out at 20 by 20, as everything does in Tinkercad. It comes out 20 by 20. So that is way too big. So M3 screws are 3 millimeters by 3 millimeters. So there we go. We've got our 3 millimeter by 3 millimeter screw hole ready to go. So what we want to do is we want to line it up exactly with that circle right there. So you can see it's kind of hard to do in this view. So this is where the orthographic view comes in and is a much better way to look at things. So if I click on the orthographic view and I click top, it's now nice and flat. You can see how much easier it is for me to get my cylinder to the exact place I want it. If I try to do this with the 3D view and I click on top, it's just really confusing. It gives me depth and I don't want depth. So I'm going to click on the orthographic view and I'm going to use my arrow keys on my keyboard. So I'm going to move over and I'm going to move up. Now you notice the arrow keys, I can't get it exactly to where I want it, which is pretty annoying. And this is where we get into turning off the snap. So I mentioned the snap at the very start. So if we come down to the, I'll close this up. We come down to the right corner here and click on 1 millimeter, come up to off, turn off. Now when I move with my arrow keys, you'll notice when I hold down, they move in very, very small increments, like tiny, tiny, tiny little increments, which allows me to get into a much better spot. Now, let's say I'm like, I want to move this like over here, and it's just taking forever. You can hold down Shift, and it will move it at double the speed. So if you're ever using a snap grid with off, and you're confused, and you're like, I just can't get where I want to go to, hold down Shift, and it'll move a lot faster. And I'm just going to move this into place. So let me get it. I think that's pretty good. I mean, it's not totally exact, but it's as close as we can get it. So if you look here, I now have and I'll go back into 3D view. And I think what also I'll do is I'll put the work plane on the bottom. This work plane here, I'll put it on the bottom so it's easier to see. Now I have this part and I have my cylinder in the exact place I want it. But we can't do anything with this yet. We need to perform what's called a Boolean operation. And a Boolean is taking one piece from another. Now, if you perform a Boolean, you have to have one piece that is solid and one piece that is negative. So right now we have 2 negative pieces. They're both see-through. So I'm going to take this bottom one. This is the red piece, the part we hook onto, and I'm going to make it solid. So I've got a solid piece and a negative piece now. So I can perform a Boolean function. So what I'm going to do is I'm going to click on my red piece right here, and I'm going to hold down Shift, and I'm going to click on my negative piece, which is the cylinder. And then I am going to come up to Group, which is this button right here. You can also hit Control G on your keyboard. There's a lot of hotkeys, and it's very overwhelming when you first do something like this, but they become more natural as you practice. And then I group. So if I group that, you'll notice, this is pretty cool, it punches a hole right through my design. And if I look on the bottom and I look up, sorry, you can see it's put a hole at the perfect spot right through my motor holder. I'll take this away and you can see we now have a hole, which is really good to put our screw through over here. Now, I'm just going to stop for a second because I've been kind of talking a lot and doing a lot of moving around, doing a lot of different things. Does anyone have any questions before I go a little bit farther into here? None? Oh, thanks. Well, thank you. I'm working on it. It's a bit bulky on the top, but we're working on it. Okay, so if there's no questions, I'll keep going. So what we want to do now is we want to get this screw over to this spot. So yet again, we'll use the work plane right here. I'll come over and I'll click the work plane and make sure it's on the right spot. And then I used a key before. I don't know if you noticed. I hit D on my keyboard, and what D does is it drops whatever object it is onto the work plane. Let me show you that again. I'll drag this like way up here, like I'll put the screw way up high, and I'll hit D, and D sticks it to the work plane. So D is very handy for just dropping things. So I'm going to take this, I'll put it over, and I'll put it kind of, it doesn't have to be perfect. Now, I didn't do an awesome job here because you can see my screw doesn't actually come all the way through my design. And that's whatever, that's okay. We're kind of practicing. Probably what I do now, and you'll notice it doesn't come all the way through, is I would chop this down. I would make this smaller. So actually, let's do that like real quick while we're here. So all I do is I grab a box, except I wouldn't grab a regular box. I grab one of these Boolean boxes, and I just bring it out, and I put it kind of over my design. I make it a little bit longer, so you can see it's a little bit bigger than the motor holder. And I would then use the arrow key and drag it up, and maybe I'd chop it about, I mean, I'm just eyeballing this, like maybe about there. So again, we're just going to perform a Boolean operation. So I click on the bottom piece, which is my red piece. I hold down Shift and I click on my top piece. So I've got them both highlighted, and I group them. And that will cut. It performs a Boolean, so it takes away. So now, if I drop this and I bring it over, it is looking much more, yeah, there we go. My M3 screw actually runs through my design. And I would have a little tiny nut right here. So I'd screw the nut on. Give me my motor chassis for this side right here. So I'd snap my motor in here, like so. I'd snap it in like that. And then I'd have my right-hand side ready to go for my motor chassis. Now, this design right here, this piece right here that you see, this red piece, actually a very simple piece to 3D print. It would probably 3D print in, I don't know, like might be like 15 minutes, depending on what size nozzle I use. So it's not a big piece, so it's very easy to make, and it's a lot better than the cardboard that we're going to use. Plus, the kids have practiced making something they can actually use on their robot design. So once I've got my piece like this, I just click export right here, and I'm just going to go through this just to show you, even if 3D printing isn't something you're interested in. You'll notice that there are 1, 2, 3, 4 different ways you can send a design off. This obj .obj file is for like if you want, it comes with like a color file. So if you wanted to bring it into a game or something like that, this would be the file you would use, a .obj file, because it has a color file in it, which if you have colors in your design, you want to keep your colors. This one is STL, so this one is used strictly for 3D printing. So if you wanted to 3D print your design, you would send it out as an STL to your slicer, which is what you use to slice it and then send to the 3D printer. So that's the STL. Down here, you don't really need to worry about that one. The more of a proprietary one. And then this one is for laser cutting, and it's an SVG, or a scalable vector graphic, which is, if any of you use Adobe Illustrator, if something into Illustrator, you often want to turn it into an SVG because you can scale it down to like a pin, or you can make it huge, and it will look exactly the same. So STL would be our friend for that one, just so if you're wondering about what the export is for. I'm gonna hit Control Z and bring that back to where it was. Okay, so we've got our right motor holder ready to go. And holding our motor. So I think probably what we want to do now is get our left one on. So let's click on the work plane. hover over the bottom. So we're back to our kind of normal looking work plane. You don't want to get too confused about what's going on. There's always a lot going on when you're using Tinkercad. Now, I could go through all of those steps again, but probably we just want to duplicate this and pop it onto the other side. So to do that, there's a couple different ways to do that. I'll show you one way. So we click it and we duplicate it. So there's a copy inside of there. And I'm going to change my snap grid to 1 millimeter because I am not going to try and bring this out. There we go. You can see I'm bringing it over. And I'm just going to kind of, let me just rearrange my position here so you can see it a little bit better. And then on the bottom, there's my rotate button, right? Now if I rotate this around, I've already got a problem. This is not going to work. You can see, I mean, I can put it on here, but I'm going to have to create a new hole on this design, and it's going to be kind of a pain. I'm going to have to go through a couple extra steps. So that duplicate method is not going to work for what we want to do. So we might need to find something else. So I'm going to click on it, and let's duplicate it again. But this time, let's use what's called a mirror. So up on the top, there's a little function. If I hit M on my keyboard, it will bring up a whole bunch of arrows. And you can see there's a bunch of different arrows. And if you hover over the arrows, I know it's a bit hard to see. You know what I'm going to do? I'm going to move this out of the way. It'll be easier to see. Let's bring this over. I'll click on it again. I'll hit mirror. And if I hover over the arrows, it shows you what mirror it is about to create. So you can kind of see the orange outlines. Now the mirror I want is a mirror on the, I believe it's the y-axis. I always get mixed up with the y and the z. So I'm going to click on this one, and you'll see it's created a mirrored copy of my design, which is going to save me a lot of time because I do not want to have to redo all of that hard work I did right there. So I'm going to bring that over, bring that up, and I'm going to kind of try and match it. Click on top. I'm going to click on orthographic, and that's pretty good. I can get closer though. I'm going to turn my grid to off, and I'm going to bring it over, and there we go. That's pretty good. I've got my right motor holder on this side ready to go, and my left one is very close, but not quite ready to go. So what I'll do here is, rather than grab one of these M3 screws, I think I'll just take this one that's over on this side, and I'll duplicate it. And then I will run, I'll have to turn my snap grid off again. I always forget to do that. I'll run my other one over to here about there. Doesn't have to be perfect. Okay, so you can see I've now got one motor holder on this side, and I've got my second motor holder, so I can actually pop my motors into place. They don't have to be perfect. And same thing here, rather than create a whole new, try to flip that motor around, I'm just going to duplicate this. Actually, you know what? I didn't notice this. I guess I can't duplicate this one because it is a component. So some things you will notice, if I try and scale them, you can see right here, I can't scale this design. Purple lines appear around it. And the reason for that is because they don't want you to scale electronic components because, first of all, they're kind of complicated and it might crash the program. And I think secondly, they just want them to remain in the same size that you have them. So what I'm going to do is I'm just going to bring my second one back by hitting Control Z, which was this one right here. And I'm just going to rotate my design back down to 90, bring this one over. Just going to kind of eyeball this. I'm not going to make this too detailed. Bring it in, and there we go. So kind of like that. They're kind of lining up. So you can see here, I've got my motor, both my motors in place. Still got my wheels on the outside. So I've got a wheel out here and a wheel out here, and my ping pong ball is still sitting out here, so not really doing much. Okay, so what I want to do now is I kind of want to get I think I'm going to get my wheels on next because my wheels are just sort of hanging out on the side, not really doing anything. So I'm just going to grab this little double arrow here and click, 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 and put it at 90 degrees. So from 0 to 90, pretty easy to do. And then pull that in, kind of pull the wheel close to where the motor is. Now I'm going to have to finesse this a bit. You can see that when I bring it in, it doesn't It's not on the right height. It's too low. So what I'm going to do is I'm going to kind of line it up. The thing with Tinkercad or any 3D design program, you think it looks good one way and you look at another way and you're like, wow, that's way off. Like I'll have some students that'll build something, it'll be way out here. And you just have to always be looking around at different directions at your design to make sure it's where you want it. So I'm going to line it up about there. I'm going to bring it over here, and then I'm going to use that black arrow and bring it up about there. Come in again, rotate it again, and attach it. This doesn't have to be perfect. I think that's good enough just for, aesthetic's sake. So there we go. I've got my first wheel on, and my second wheel. I can kind of do the same thing. Bring it over. Always good to practice. Snap it up. Bring it about to where it's supposed to be. I'm just kind of eyeballing this. I'm not really sure exactly. And then use the arrow to bring it up to about there. That looks pretty good. Like I said, it doesn't have to be perfect. They're kind of set. So you can see this is okay, but the problem here is my wheels are going through my plane. They're literally underneath my plane. So what I want to do is I want to bring my entire design up in the air. Now you can click on individual pieces, obviously, and lift them up and down, but we want to bring everything up. So what we're going to do is we're going to left click, and if you remember at the very start, this bounding box, this orange dotted line. So if you bring that all the way around and release, it highlights everything, like everything at once. So if I click that and pull up, you can see I'm lifting everything up in the air. So I'm just going to put that about there. And I think it's still a little bit low, actually. Let me come down, and you see the wheel is still a bit below there we go. That looks pretty good. So I've got my design sitting on the work plane. I've got these extra screws. I'm not going to worry about those. And I'm kind of almost ready to start on another piece of my design. I'll just pause there for a second if there are any questions about this process or how to use this program, or this is just one way that I'm showing you how to use it, but there's many other many other ways to use it across different grades. So if anyone has any questions. This grade 7s, I have basically what I do is I build out tutorial videos for them. So for example, this right here, no. No, this is a grade 7 project. So like I said, sorry, grade 5 through 7 projects. So 5s would probably take like there's 6 videos, so they probably take, each video is about 10 minutes. So they probably take about 2 to 3 classes, hour classes, probably about there, probably about 3 classes to build out this entire design by themselves. It's not going to look exactly like this, but the process is they follow it pretty quickly. Kids pick up on this very quickly. 3D design in probably about 3 classes or so, they'd have something like this, very close to this built. This process that they're building here is just a mimic of what I've built. The kind of creative process comes around when we talk about, okay, so this is the design that I've created. Now I want to add something on the top of this design that holds a needle that can pop balloons. Because what we do with these robots is they have little balloon popping kind of competitions, and they have to build out something that attaches to the top of the robot that holds a needle that can pop the balloon. And how they do that is it's a prototype process, right? They have to build that out and show how that works. So I would say 5s would take about 3 classes to do that. In terms of time, 9s would probably be like 2 classes. 8 or 9s probably 2 classes. They can build stuff pretty quick. Any other questions along those lines, or? Okay, so let's go into the next portion. Now, this part right here, this ping pong ball is to scale. So I have a couple ping pong balls here. I just measured it out. A really handy tool, if you get into designing things in 3D printing or anything like that, is a digital caliper. They are a necessity for measuring small measurements and getting precise measurements. So we have like digital calipers through all of our schools in different classes as a set. that the students can use to open and close and measure out things precisely and then bring it into Tinkercad. Sorry, I had another question here. My thing's not scrolling up. Yes, the video tutorials, I gave them to UBC yesterday. So they go through this exact process right here. And yeah, they'll be on the website along with the other tutorials I've built out. So yeah, you can totally access that. It's exactly what we're doing here, but without me talking so much. It's more like to the point. So they'll be there. I think there's 6 videos. They also have a link into the kit that I mentioned, the Kitronics kit for building out the actual robots. I don't know if any of you have tried out microbits before or have heard about microbits, but the really cool thing about this kit is with the microbit attached here, you program another microbit to send it radio frequencies that control the speed and the direction of the motors. So you have one child with the microbit controlling it, and the other microbits obviously on the robot, and then they kind of have little we have like a little soccer game with it, with robots, or we have balloon popping with it, or we have a challenge where you try and get as many ping pong balls into an area as you can. So this is kind of like a standard introduction to robotics that our students go through in our district, just to kind of give you a background of how we use this process and what we do. I'm a big fan of practical projects that have a tangible outcome, that you can like physically see. And that's why 3D printing and Tinkercad are such good friends. And tying electronics into it and robotics is a nice addition. So this bar right here, if you look at I'll go back to the design here. It's a bit hard to see, sorry. Maybe I'll make it into a slide so you can see it a little bit bigger. You can see this is, it looks so janky, like all put together. So it actually works really well though. It kind of looks like a jalopy or something like that, but it actually works. This rolls on the front. So you can see, I don't know if you can see this board, but on the side of the board, and just like I have in my design, there are these little holes right here, one here, one on the back, and one on the far back there. And those are the M3 screw holes that you can put your M3 screws that we attach things onto. So I was thinking to myself when I'm initially making this design for the students to copy was how can we get the ping pong ball a bit of a better holder for the ping pong ball. So in the front right here, the first thing you want to do is I'm going to come to the top view. Like this, and I'm going to just click on the orthographic, so I'm nice and flat, is you want to have some kind of attachment to attach to the front of your motor board right here. So if I come over to the side, if you recall, we're using our work plane tool a lot. So I'm going to click on the work plane tool, come over, and I'm going to hover and just make sure I'm attached to the work plane on the motor board. So there we go. If I look down, you can see the work plane is now attached to the top of it, which is exactly what we want. Then I'm going to grab my regular box, and we're pretty much sticking with boxes today, but like I said, there's a lot of other shapes, but we're going to stick with these. And I'm going to bring it up, and I'm just going to kind of drag it all the way down to the end. So that's sitting at 73 millimeters. So if I look at it here, you can kind of see, I'm just right clicking, that is pretty good. I'm surprised it actually fits so well onto the board, but it does. Now, obviously, we're going to bring this up a little bit to maybe about there. And on the bottom here, you can see, I'm just going to zoom in a little bit. I'm going to bring it back to about there. So I have it sitting nicely right on top of my robot. I've just kind of stretched it out into a more rectangular shape. So I'm going to grab the top, this white square right here, and I'm going to bump it down. Now, you might have noticed that I am pretty consistently using 3 millimeters as my height for my attachments to the motor board. 3 millimeters, I find when you're 3D printing, is a very nice standard thickness that doesn't take too long to print, but is strong enough to hold things. So generally through my prints, or when I'm designing something, I use 3 millimeters as a standard. It's just, it's worked pretty well for a lot of stuff we've built out. Okay, so if you recall, now that's great, I've attached that, but I cannot see the hole in the bottom. So I'm going to show you a different technique. So if I click on this and I hold down Alt H, actually, not Alt H, I think it's maybe Control H. There we go. Sorry, I get mixed up sometimes. So Control H, if I hold down Control and H, it actually hides the piece. Like it totally makes it disappear. Sometimes you don't want to just see through it, you want it gone. So Control H hides it, and if I click on this light bulb, it brings it back. So I'll do that again. So Control H hides it, which for this piece maybe is a little bit nicer. I don't want anything in my way. So what I'm going to do is I'm going to come over to the side, and there's my cylinder. I'm going to pull that over. And my cylinder, if you recall, and actually I'll open up the cylinder here, and I'm going to zoom in on the cylinder a little bit. You'll notice it'll be easier to see if I make it a solid. Um, it's broken up into actually 20 sides. So if you want it to be smooth, you can bump this up to 64 and you can get it very smooth around the edges. It doesn't really matter for what we're doing as long as you don't make it like 12, probably 20 is fine. But understand that you can also bevel the top of it. So you can, if you wanted to do that, not for this design, I don't. And then the segments, I don't know if that's attached to the beveling. It must be, yeah, it's attached to the beveling. So you can see, you can make the bevel smoother like a fillet. But we're not really worried about any of that right now. We're going to keep it nice and easy. So I'm going to click down here. I am going to tap on the 19.97. I don't know why it says that now, that number, but I'm going to type in 3. And then this one, I'm going to type in 3, because if you recall, an M3 screw is 3 millimeters in diameter. And I'm going to bring myself to my top. I'm just kind of repeating the work process that I did for the other piece. And you'll notice again, I can't snap. So I'm going to bring this down here under my snap grid. I'm going to turn that to off. And I'm just going to position, see if I can do this, position this. This is actually probably what I should have used on the other piece rather than making it a hole. I should have actually hit it because it's a little easier to see. All right, so I've got one here, and while I'm here, I think I'm going to do the other side. Now, if I get this right, I'm going to turn this to 1 millimeter. I'm going to duplicate it. So let me go to my top view. And let me move this out of the way. I've duplicated it, and I'm just going to, oh, actually, I don't think I did duplicate it. Oh, now I'm in, there we go. So I'm going to duplicate it. So click that button and bring out my other copy and put it, is it going to fit? I think it's like exactly, let's see. It is. It's bang on. Sweet. Well, I got lucky. So that is perfectly in line. I've now got my 2 M3 screw holes like set up. Now all I need to do is click on the light bulb, and that brings back my piece that I was working on before. So I've got my 2 booleans, negatives, and I'm going to hold down shift. I'm going to click that one, and then I'm going to click that one. And then finally, as you remember, you need to click your solid piece on the bottom to solidify the entire thing. And then I'm going to click on group. And that's going to cut that out and give me those nice holes that I want before. Let me go back to 3D and zoom in. You can see now I've got that hole there, and my other one on my other side I think looks pretty good too. Okay, this is great. Now I've got a piece kind of hanging out at the front that I can attach onto. So before we like move ahead and start like building out the next piece, let's bring our M3 screws over. So I'm going to bring this one over. If you recall, I hit D. D is drop. So that drops onto my work plane. I'm going to bring it over here, and I'm going to go to top view, and I'm kind of repeating the same process. I think I'm just going to kind of eyeball this and push it in like that. And then what I'm going to do is I'm going to go to top view again, and I'm just going to Control D. Control D, if you recall, is our duplicate over here. And I am going to bring my second copy, put it right there. Perfect. So now we have a front piece, and I'll come back to this design here, that we can now 3D print and attach to the front of our robot right here, which is going to be pretty handy. So next up, we need to somehow get it out here and get it attached or onto the ping pong ball in the front. Now, this is a bit trickier. I don't know how far out I want this ping pong ball. I mean, it's kind of, it's hard to say exactly where I want it. So I'm going to show you another tool. So if I click on the red piece right here, and I hold down Shift and I click on the ping pong ball, and I go look at the top. Over here, this is a tool we haven't really talked about yet. It's an align tool. So it align things up perfectly. So center, sides, things like that. So if I click on it, you'll notice these little kind of black dots appear, and each black dot will align it in a different place. You can see where it's aligning the ping pong ball. If I push over here, it's going to align it over here. Now, if I click here, I think, there we go. It aligned it perfectly in the center, and that's what we want. We don't want to have any human error. So this align tool right here is really handy for lining things up when you don't want to do it manually. You want to set it up so it's like perfectly so the computer gets it ready for you. So now that ping pong ball is perfectly aligned with the center of that red bar. And now we want to create something to kind of ring around the ping pong ball to hold it. And let me show you. Actually, no, I won't show you what I'm going for. I'll just try and build it, and then you can see it in the end. I'm going to make a 3D view, and I'll kind of look at it this way. Now we're going to come down. Now I could use a cylinder, use a hole, and make like a hole for it. But I mean, there's no point in doing that when they already have a tool that has that ready to go. And that is this tube right here. This tube is handy for building that out. So I'm going to grab the tube. I'm going to bring it out. I'm going to go to top. And let's see here. Again, I'm going to line this up. So I'm going to click on top. And I'm going to get the tube the size I want it. So first things first, I am going to stretch it out. So let's see here. Let's go to a top view. And now if I hold down Shift on my keyboard, I'm going to do perspective. If I hold down Shift and I drag, it will go proportionally. If I don't hold down Shift, it's going to alter the size of the cube, or the size of the tube, which is not what we want. We want it proportional. So hold down Shift, click here, and pull. And I think that might be about the right size. I mean, I'm just kind of eyeballing this. It doesn't have to be perfect. Now that I've got it kind of the right size, I'm going to line it up perfectly with this bar here. So again, I'm going to click on the bar. I'm going to hold down Shift. I'm going to click on the tube. I'm going to click on the align. And I guess, oh, here it is. Sometimes they can be difficult to see. So there's the black dot right there. I'm going to click on that and see it aligns it up perfectly with the bar on the top, which is exactly what we want. Now that is far too high. So let's click on it. And I'm going to lower it down, and I'm going to use my standard 3mm because I find that's pretty good. And I'm feeling like I might need to make the tube a bit bigger. It's not really going to wrap right over top of it. So I'm going to bump it up a little bit to maybe 39. And when I do that, obviously now it's out of alignment. So I'm going to have to realign. So click here, click here, click here, and align again. There we go. So pretty good. That's looking not bad. And then I can lower this, sorry, not the ping pong ball. I can lower the tube down a bit so it sits on the ping pong ball. And this would kind of hold the ping pong ball in place while the robot is moving forward. It's not a great wheel on the front of a design, but it's pretty good for what we want to do for what we're building out. So I've got that set up. Now I just need to find a way to attach it to my bar, because once I attach it to the bar, then I've basically got my front of my robot built and ready to go. So I think probably the easiest way to do that is to come up to the top up here, click on my bar, and just duplicate my bar. So I'm just making a copy of the bar, and all I'm going to do is I'm going to drag out the copy. And then I'm going to squish the copy in on this side, and I'm going to squish the copy in on this side. So you can kind of see it's got the holes in it, which is a bit weird, but that's okay. And you can see it's pretty close. It's still not attached. You can see there's still a space here between the two, but I've got my basic kind of hook right here that I can hook it onto. So I've got my extending piece right here, and I'm just going to duplicate it again. So I'll make another copy, and I'll bring the second copy. You can see the second copy is inside of it, and I'm just going to lower the second copy down. So let me back away from here, put this on the bottom, and you can see now this is attached to this is attached to this, and this is attached to this. So all of these pieces are now connected with each other, which allows us to make a print which would work pretty well. But they're not attached yet in the program, but we can see what it would look like. So I'm going to click on this one. I'm going to hold down Shift. I'm going to click on this one. Hold down Shift and click on the little one, and hold down Shift and click on the tube. So I've got up here, it says I've got 4 shapes clicked. So I'm going to click on the group, and now if I grab this piece, you can see it is a total separate piece from the design. So basically, once I've got all of my pieces printed and ready to go, I think I've got it pretty much how I've got it built out here. Yeah, similar. It's not exactly the same, but this is kind of your finished design right here. It would look something like this for a basic design that you could print out and get started with. Now, I mentioned before, once the students have this basic design printed out, and I would pre-print this for them so it's ready to go. The next part, once they got comfortable with using Tinkercad and they feel a little bit like they can actually build something out in it, is printing out the piece that would attach to this. So, for example, like I said, we have a needle on the top for some balloon popping. So the needle has to hang out the front of the design. So the students would kind of look at, okay, well, I have this piece on top here. How can I attach something modular onto here that I can snap fit in and put a needle through right here? So once they've built this basic chassis out, then they'd have the skills to start talking about, okay, what can I do to start building out and adding to this piece right here? So what I do is I kind of grab like a cone. Oops, sorry, cone's a little hard to grab sometimes. And I would just kind of grab it, I would extend it out, maybe make it like quite long, and maybe shrink it down and say, okay, you have a needle, let's say like this long. That's a pretty long needle, but and then now you have to get this and you have to figure out how can I get this on my design. So when I move my robot around, it has that piercing ability to pop the other robot's balloons, or I can maybe flip it. I can put in the back of my design, or I can put 2 in. So I can pop this way and I can pop that way. So they start thinking about different ways to attach this part on. And they have M3 screws, a whole bucket of them, and some little kind of screwdrivers that we have for them to practice with. The nice part about this is if you have one 3D printer per school, if you 3D print the parts out beforehand and have it ready to go, them 3D printing the pieces that attach to it is fairly easy, and it doesn't cost very much. It doesn't cost much time either. But even if you don't want to do any of that, you don't want to bring this into 3D printing, it's a great way for students to create practical practical designs that you can use in real life that you can actually bring into reality. Even if they don't bring it into reality, it's great practice for 3D design. So going back into Tinkercad here, let me jump out into my design space because we've got that basic one done. I'll just jump into my 3D designs. You can see here, we do a lot of different things. So for example, this is a room design. Students were creating rooms and creating decor for classrooms. This was a rocket design. You can see here students were building different types of rockets for Mars missions. This was actually a robot design. And this one here, you can see down here is I'll actually go into that. This one's pretty cool. Is a Mars based design. So these weren't 3D printed, obviously, but these were cool designs for designing out places for people to live if we did go to Mars, which who knows when that's going to happen. We also do inclusive playground design. So one of our schools is being built, and we were looking at designs for playground for people with disabilities. how to make sure that they can enjoy the playground as well. Let's see what else we've got here. Um, these are the key. This one is a really interesting one, actually. I don't know if any of you use Minecraft in your classrooms. We use it quite a bit in our district. So what the students do is they go into Minecraft and they build houses, like basic houses, and then they bring those houses into Tinkercad, and they put a hole in the bottom of them. They put a hole in the top of them, and then we 3D print them, and we put in these lights into them, these LEDs inside of them. So they're Christmas ornaments. It takes a little while to build it all out and get it done, but once they're done, they have a Minecraft 3D printed house that they can hang on their tree. You can see this is a full class set of, how many we got here? We've got 26 different houses. So you can combine Minecraft with Tinkercad and build some pretty cool designs. This is a bit of a bigger project, takes more time, but the end result is some pretty cool designs and something that students can actually hang on their tree and use. Um, yeah, so there is a lot more in here, but I'm down to the last 5 minutes here, so I'm going to kind of open it up, and if anyone wants to pop on and chat on the mic or say anything in the chat, thanks for watching. And I've just I know I ran through a lot there, but yeah, it's a great program that we use a lot. So how do you import them from Minecraft? In Minecraft, you have what's called an export block. So you put it down, and on the X, Y, and Z, you can alter this to the X, Y, and Z. And then you basically put that block down and you wrap that block around the object. So it doesn't, whatever inside that object, you export it. It exports it as a STL, and you take it into a, yeah, then you take it out and then you put it into Tinkercad. And once you have it in Tinkercad, then yeah, you can do whatever you want with it. Sorry. Don't, yeah, I wouldn't do that. I would give them their own project because they'll start dragging stuff around and it'll just turn into a big fight. I've tried it before. I thought it was a good idea. But it's like different people dragging different things around. So I would get them to maybe build different parts and then you can bring them all into one place. I'm sure you could. Yes, I'm sure you could tie it into. Sorry, I'm just looking at the questions here. Tie this into Black History Month. I haven't done anything with that, um, but I'm sure there is a way you could design something, perhaps a monument in Tinkercad that would be something you could use for representing that month. I've never really thought about that before. Is there a link to the project you've used in the instruction videos? Um, there's not a link to the project I have here, but there's a link to the instruction video I just did. If you want to, yeah, if you want to get stuff from me that I use in my like every day, you can email me at uh, that email right there. That's my district email. So if you want to shoot me an email, I can let you into my gallery and you can see some of the stuff that I make. But the instruction video, we have, like I said, Edith Landau will be putting that up for you to use. Let's see here. Sorry. Yeah, it's a lot. The circuits is cool too. The neat thing about the like I'm just incorporating the microbit in now, and I'm finding it's really great for students combining different things together. It's a lot of little bits and pieces, but once they get it, they can build some really cool stuff. We have students that do like a shoe design and they build like shoes online and then they present them at a show. There's a lot of really cool uses for it. No worries, anytime. Yeah, thanks so much for everyone for watching. I know it's like kind of getting hit with a fire hose of information. It's like a lot of stuff, but yeah, I think it's an amazing program and it's just one of them. Yeah, Arduino is much more advanced. If you're good with Arduino, then microbits would be a lot easier for you. If you go to microbit I think it's Microbit Maker. I think it is. Hold on, let me check my let me check here. Microbit, there we go. Make code for Microbit. This is a really cool site right here that you can get started on Microbit and do all kinds of interesting stuff with those designs there. Let me just figure out. There we go. I'm going to stop sharing my screen and I'm going to bump back to me. Hopefully you can see me right here. Sorry, lots of stuff moving around here. Yeah, yeah. Report cards are, yeah. That's a grind. You got to get through that. Yeah. Thanks everyone so much, and I'm going to be putting more of these on. I did one on game design last week or 2 weeks ago on CoSpaces, and I am doing a 3-part series on game design and storytelling with Make Code Arcade. That seminar, no worries. That seminar is full now, but I'll be coming out with more stuff for Edith Lando and hopefully chatting with everybody more. And yeah, it's fun.